0.1 molar HX, but this time HX is a weak acid, and you're given the Ka is 1.8 times 10 to the negative fifth. This is, in fact, the Ka of acetic acid. So let's solve this problem. You have HX gives you H plus X minus. What's our initial condition? 0.100 molar HX. Assume negligible concentrations of H plus and no X minus. What would be your changes? Minus X is going to go forward, right? Plus X plus X. So our equilibrium concentration would be what? 0.100 minus X, X, and X. How do I solve for X? I'm going to say that X squared, okay, Ka, is H plus times X minus over HX. So it's going to be equal to X times X over 0.100 minus X. Okay, and what is my Ka? It's given as 1.8 times 10 to the negative fifth. So you have a quadratic equation here. Okay, so you solve for, work out the algebra and solve for X. Can we simplify? No, because this is 0.1 minus X. So that's X squared over 0.1 minus X equals 1.8 times 10 to the negative fifth. I'm going to write it this way so you don't confuse that times with X, okay? So you have to solve for X there. You can use a quadratic equation, but you can make a simplification. Given that this is small, you can assume that 0.1 minus X is essentially going to be 0.1. Negligible compared to 0.1. Is that a valid assumption? You have to check in the end. If not, then you're out of luck. You have to go back and actually do it using quadratic equation. But let's say that X is in fact small enough. What would it be? Then you would say X squared over 0.1 would be equal to 1.8 times 10 to the negative fifth. And so what would be my X? This is easier to solve now. I can say X squared equals 1.8 times 10 to the negative fifth times 0.1, which would be how much? 1.8 times 10 to the negative 6, right? That's my X squared. So what's my X? What's the square root of that? 1.8 times 10 to the negative 6, and then take the square root. How do I take the square root here? Raised to the power 0.5. Oh, here. The second root, yeah, 0.0013. So it's 1.34, 1.3 times 10 to the negative 3. Okay, 0.0013. That's my value for X. Is that negligible compared to 0.1? Compare this one. This is 0.0013, and this is 0.100, right? So this is 0.100 minus 0.0013. How much error am I making by making that assumption? My error would be over here in the third decimal place, right? That's 1 part of 100, 1% error. You're within, if you can get it to about 10% error or less, you should be okay for most practical purposes, okay? So you would say that's a reasonable assumption. So we'll go with that, okay? So, so what would be our X then? Our X is 1.3 times 10 to the negative third. So going back to the question, we now figured out what our X is, right? We figured out that this is equal to 0.0013. That's 0.0013. So what's our pH? pH is negative log of H plus at equilibrium, negative log of 0.0013. And what's our pH going to be? 0.0013, take the log, 2.89. Okay? So our pH is 2.89. Okay? That's your pH. What would have been the pH if this was a strong acid? If you had a strong acid, X would have been 0.1, right? And so that would have been your H plus, and your pH would have been negative log of 0.1, which is 1. So you see, it's not quite as acidic as we would expect a strong acid to be. So if you have to compare two acids, two monoprotic acids, one strong, one weak, if they have the same concentration, which one would have a lower pH? The stronger acid would have a lower pH. The strong acid would have a lower pH.